All right. Hi, folks. My name is Aaron G. Clough. I'm here to talk about Django channels in practice. Before I launch into this, folks are aware of Django, right? I don't expect channels. Channels is part of what I'm going to talk about. Very good. OK, so for the record, before I launch totally into this, code doesn't fit well onto a screen. So I'm sorry there's not going to be code today. I'm going to talk about just sort of how it works. There's not going to be code up here. I'm sorry. Those of you in the back won't be able to read it anyway. So it's for the best for everyone. Who am I? Frankly, I'm just some guy. I've been doing security since about 99 or so. Started in Perl, moved to Python sort of mid-2000s. Presently, I'm the VP of engineering for a startup based out of Old Town called King and Union. We do a bunch of threat intelligence, and I'll actually use our product to show you what some things you can do with Django channels is, because this talk comes from my experiences building a product with channels as its backend. So let's get to the fun stuff. What is Django channels? It's a way to do asynchronous support, specifically WebSockets, in a Django app. Obvious next question, what's a WebSocket? I heard that. So WebSocket is a way to do asynchronous communication in your browser. So for example, your usual web server request, or your web request is going to be your browser makes a request to a server, it gets an answer. But what if that's not the communication pattern you're looking for? What if it's a communication pattern more like your server's going to send one thing, and then maybe 2 hours later, it's going to have another thing to send, or maybe 30 seconds later. Or maybe the client's going to make requests sort of asynchronously, and the server may have more than one response. Rather than trying to say, I need to do fast polling to see if there's anything new, or trying to do something fancy with HTTP2 and multiple requests, WebSockets is designed for this kind of communication pattern, where either side of a connection might just want to send something at an arbitrary time, and the other side should just respond to it. So if you have stuff that your web server might want to say back to the client without the client initiating another request, WebSockets is the way to go. Channels lets you use all of the batteries included part of Django with that communication pattern, which I think is a whole lot of fun. So what's it for? The obvious use case for this is chat, because it fits that communication pattern really well. You don't know when the person behind the keyboard is going to type a message to somebody, and you don't know when anybody else they're chatting with is going to send a message either. But you want those messages delivered really quickly. As frankly, you want them delivered as close to real time as you can manage. So chat is a beautiful example of this. Each client has a connection to your server. They send something down to the server, and when the server has a response for them, it sends it immediately rather than waiting for the client to say, is there something for me now? How about now? How about now? How about now? Because that's a really poorly scaling communication pattern. You don't want to be doing regular polling. You want to have just one open connection and send messages down it asynchronously. And if you're using chat, since everything's going through this back end, you can set up chat bots, you can set up filters, you can set up all sorts of things because you're seeing the traffic go through you. But chat's kind of only the beginning. You can do all kinds of fun stuff with this. There are games you can do with it. There's a web game called agar.io that runs all of its communication patterns over a WebSocket. You can do collaborative editing. I'm pretty sure Slack's website, and possibly even their actual desktop app, uses WebSockets to do all the communication. You can do collaborative editing. We'll actually demonstrate some collaborative editing with my company's application, because this is what we do. There's another thing built into the browser called WebRTC, which lets you do video calls and video conferencing through your browser. And that needs to do signaling to say, this user can support this audio codec and this video codec, and this user can support this audio and video codec. And rather than trying to forward messages and requests and all that, you just have each of them make a WebSocket to your central thing, have each of them send those messages to each other, and you're done. So you can do all kinds of fun stuff. For example, let me just get a quick demonstration of this. So this is two users looking at the same graph. The back end of this is Django channels and WebSockets. One side edits something, the other side sees it almost immediately. So you don't have to just do chat. You can do all kinds of fun stuff with this. All right, so you want to do this. How? So obvious first step for Django, you install the channels package with pip or however you're doing your package management, and add channels to installed apps. Next, you're going to have to define a couple of URLs, because your WebSocket is a special connection from your browser back to the server, and you need to tell the server itself, here are the URLs you're going to expect WebSocket connections. WebSocket connections look a little like HTTP, but they're not. They sort of fake an HTTP header to get past all your web filters. And then they have a little special header that says connection upgrade. And when the server receives that, it says, lovely, I'm leaving this connection open forever. And doesn't close it and starts handling it like a WebSocket. So you need to tell Django which URLs those are going to be and where to look for those. The way you do that is in the routing.py file. It looks a lot like urls.py in Django. And it actually behaves much the same way. You have a site-wide urls.py and then an application-specific routing.py. In there, you define which URLs are going to be WebSockets. You can have more than one. We've got 2 or 3. And you tie those to a consumer class. And we'll talk about those in a minute. And that's really all you need to do first. Next up, got to define the consumer class. This is basically one per URL. And what this is going to do, it's going to define what happens when you receive a message down this WebSocket. And it's going to look for certain methods defined on this class. At minimum, you need connect, disconnect, and receive, which do kind of what their name implies. And if you're doing something special where they have a helper one where you can inherit from a class that says, I'm only going to send JSON down this socket, in which case you don't need to receive, you need receive JSON. That's the bare minimum. You can get fancier, and we'll talk about getting fancier with that in a minute. So what goes in here? One thing to keep in mind, and this is where Channels really deviates from Django. When a customer makes, or when a client makes a connection to Django Channels, makes a WebSocket connection to you, Channels is going to instantiate one instance of that consumer class and leave it open and leave it instantiated for the entire lifetime of that WebSocket connection. So if your user connects to this thing and leaves the page open for like 3 weeks, I've seen as long as a month for some of my users, there is one Python instance of that consumer class living for that long, for the whole time, which is really different than Django. In Django, you call a class, you have a method on a class for your handlers, and it gets called once, and then all that state goes away. And it gets called a second time, and all the calls are getting made again. That's not true for Channels. Every event that comes down the socket for a particular user comes to the same instance of your consumer classes over and over again. The fantastic value for that is you can keep state suddenly. You don't have to redo queries if you know they're not going to change between events. I'll talk a little about this for a minute, but since you've got an instance, you can slam stuff up onto the self object in Python and keep it between connections, between events. You can keep state between events, which is interesting and a little dangerous. I'll talk about that in a minute. There's one other thing that Channels gives you by default, which is something called groups, because a really common pattern is you want to, like a chat room, you want one person to talk and a bunch of people to get that message. You can do that fairly easily. It comes built into Django Channels. When the consumer is instantiated, it will get a class variable called reply channel. And you can just add that reply channel to a group, and you create a name for the group however you want it to. And Channels will handle saying, I want to send a message to this group. You added all of these reply channels to that group, therefore this message goes to all those reply channels. It's a quick shorthand to be able to say, anything that comes from this person to here goes to all of these people. You have to track yourself who's in that group, because Channels will not tell you, but it's still a useful shorthand. So before you start writing code, because the first thing anyone's going to want to do is just start slamming stuff down, Channels is so different from regular Django, you're going to want to think about this a little bit. So the first thing I'll say to folks before you start just shoveling code out there is spend some time doing design thought. So first up, you have to think about which parts are going to be REST, which are going to be HTTP, which are going to be WebSockets, because they're different. Some parts of it will work really well as straight REST. Our application, there's only like 3 or 4 actual full-on HTTP requests to just load the initial site. Everything from that point on is either a REST call or a WebSocket call. But we had to decide which ones those are going to be, which ones are appropriate to be basically real-time events, which ones should be REST calls or just sort of status and metadata type things, and which ones were sort of other. There is a special kind of class, because I was mentioning these consumer classes you can make. There's a special kind of consumer class you can make called a worker. And the idea for that is it's something you want to handle asynchronously, but isn't tied to a particular consumer, isn't tied to a particular connection from a customer. We'll talk about some examples of what those are in a minute, but there is another kind of thing that you want to plan for when you start talking about this. The other big thing for channels is, because these are just unformatted blobs of whatever going down the JSON, going down the WebSocket, you need to standardize your communication. For HTTP, it's pretty straightforward. You're getting a post, and the post formatting is this way. For a WebSocket, it's a thing is getting sent by your UI down this WebSocket to you, and you are sending a thing back to them. That thing is totally undefined by channels, or frankly by any of the JavaScript. So if you're working with the UI team, or even frankly just working with yourself, you need to standardize what are we going to send, how are we going to send it. Are we going to trigger on a particular key in there to say this is like an action type, or what? What are the keys going to be in this JSON if we're sending it? You need to standardize that ahead of time, because you're going to be in a lot of pain if you're just kind of making it up on the fly. And there is no standardization that comes by default from this. Next up, I was mentioning you have to build the consumers. One thing to keep in mind, I mentioned the consumers live forever. It is really tempting to cache things on self. One of the mistakes I made really early on was, again, in this thing, so each of these is a workspace to us. So I've got one workspace, two people looking at the same workspace. The workspace has metadata, things like the start date, the title of it, an end date, things like that. When I first started writing this, I thought, I'm going to take the Django object that represents that metadata, the workspace object, and I'm going to slam it up onto self so that I never have to do that DB lookup ever again. That's a mistake, because these connections last for weeks, as long as a month in some cases. If somebody else, through some other interface, changes this data, and then you do workspace.save on the WebSocket side, you just undid somebody's changes. And that's the thing you have to think about. It is really tempting to use self a lot, but don't treat self like a cache, because it can't be. I'll talk a little about this later. The Django REST and Django HTTP side of things doesn't talk to channels unless you make them talk to each other. So self is super useful for stuff, but it's not really a cache, so you can't really treat it that way. Also, you want to think about manageability when you're building these. For us, I mentioned there's 3 event types you have to handle: connect, disconnect, and receive. For us, we ended up having a lot more than that. We have create, update, delete for nodes, edges, clusters, notes. There's like a dozen of them. So we ended up having like 40 or 50 different kinds of events that can come down the WebSocket. Having one method for each of those risks having one consumer class that is thousands and thousands of lines long, which is completely unmanageable. We ended up breaking that apart into a bunch of different classes and then having them all inherit back to the main one. But that's the kind of thing you should think about. If you're going to have a fairly complex fairly complex event structure, don't just slam those all into one class, because it's going to be unreadable and unmanageable. There is one other thing in Django or in Channels I haven't mentioned yet. Channels is making use of the new async features in recent Python. So you can write fully async consumers. One problem with that is Django itself, like the ORM, is not async. So if you're calling out to the Django ORM, you need to do some special magic to tell it, okay, this is a synchronous class, I need to not be doing that. Or if you're trying to do async code and you've written synchronous code, you need to do other special things to go the other way. Django Channels has some special helpers to do that, but you need to know that you're doing it. You need to know where to sort of sprinkle those. Frankly, because we end up calling the Django ORM, and I didn't want to have to think about that too much, I never wrote asynchronous classes. So just FYI, you can do it, but if you ever touch the Django ORM, you have to go from asynchronous back to synchronous. It gets hairy. So feel free to do it if you want to. We never did. I'm a security guy. The tool we write is a security tool. I care about the authentication side of things. It is fairly simple to wire up the consumers to Django's authentication. In that routing.py I mentioned earlier, you just wrap the URLs in another method from Django Channels to say, yes, this should have the authentication stuff from Django. In fact, there's another one that you can wrap that one then in to turn on something called origin filtering. Origin filtering, I think you probably want it, but they don't turn on by default. Origin filtering is kind of like cross-site request forgery protection for WebSockets, but not really, because it's not a form, it's a persistent connection. What origin filtering does is it checks that initial request that has the upgrade header to see what the source of the request is from. Is it from your URL? Is it from some other URL? Origin filtering says check the authorized hosts in Django to see if the source host for this WebSocket connection is in authorized hosts. If you don't turn that on, it will accept WebSocket connections from anywhere. You may want that. I really didn't. So I turned origin filtering on. If I were left to my own, or if it was my decision, I think origin filtering and authentication should be on by default, but that's not the decision they made. You have to wire that up yourself. So deploying it, there's a couple ways to actually roll this out. Channels uses what's called an ASCII server rather than a WSGI server. If you're used to Django, you can use a WSGI plugin to Nginx or Apache or something and just run the Django code straight in the web server. Channels needs an ASCII server for an asynchronous SGI server. For the most part, you could just put that in the web server, have Django Channels act the same way, and just replace WSGI with ASCII, be done. You can also run a standalone ASGI server and have your web servers just forward the requests to the ASCII server. If you're running workers, you have to run a standalone ASCII server anyway. I'll talk about workers again in a little bit. But that's really the two patterns. You can either run it all directly in the web server or have the web server doing forwarding. One thing you may want to think about for this was when you start getting to load is splitting out the WebSocket and regular REST HTTP code. Because I mentioned previously, the WebSockets are persistent. So you're going to have an instance of this running the whole time. It's going to be taking up CPU and taking up RAM on that machine. Whereas your HTTP requests, your REST requests are very transient. It answers the request, it's done. It answers another request, it's done. But you've got this WebSocket, even if the WebSocket is not sending any messages, as long as the connection is open, there is this instance in RAM running on the machine. So one of the things to think about for scaling is you may want to split out the WebSocket stuff from the REST and HTTP stuff just to scale them independently. So that if you have 500 WebSocket connections that are just sitting there, that hasn't filled RAM on your web server and prevented it from actually answering any just regular HTTP requests. And then, so let's talk about the fun stuff. So that's at the core. This is the normal things you're going to run into. Here's the stuff they don't tell you is going to happen. Channels will do event routing. So you can have two instances, two of those class instances I was talking about. You can have them send messages to each other. Say maybe user 1 wants to send a special message to user 2, and you can have the instance for user 1 send a message to the instance for user 2. Channels will auto-route those, which is actually really helpful. So you can say, this event goes to this reply channel, and the event type it will look for a method on this class with that event type automatically for you. You don't have to tell it, here's the routing for this. On the other hand, a message that comes in from the client will always get handled by receive. For me, that was backwards. I have 50 different event types coming in, and only one going back out. So I actually ended up reversing that whole communication process, which was kind of a hack, but the communication pattern assumed by Django Channels is very complex communication between clients and very simple communication to and from, and that's, for me anyway, exactly the opposite of what I needed. I've been mentioning these consumers are long-lived. They're long-lived in theory. In practice, the consumer connections are going to die. The consumers will get shut down whenever a client disconnects, and they'll run their disconnect method automatically when the client disconnects. The client can disconnect for all kinds of really random reasons. Maybe the person is on their phone and they drove into a tunnel. Suddenly this client's gone down now. So one of the things you may want to think about is, do you need to have them reconnect? And we mentioned the workers here, if there's a task that needs to happen, whether or not the consumer is connected, you cannot count on it being run on the consumer, because it's going to get killed because maybe the client's firewall decided this connection's been open for too long and just swats it away. That's going to happen. So there's a thing called workers, which are also instances of Django channels, but are basically just worker queues. You throw events at them, and they do that thing, and then do whatever you tell them to do as an output. But they run independently of a WebSocket connection. It's just a convenient way for channels like events to communicate saying, I need this done independently of a user. For example, I'll keep coming back to our product here. These are like domain names, IP addresses, URLs. When people add this to our system, we want to go look them up. We want to say, geolocate the IP address, do a whois on a domain name, things like that. We don't want that to fail if the user disconnects. So what we do when a user adds like an IP address to this is we launch a worker command saying, do a lookup on this particular thing, whatever it is. Because if the user just tosses an IP address at us and then disconnects, we don't want that lookup process to get cut off, because the consumer is going to reap and shut down. No matter what else it's doing in the meantime, it's just going to shut down. So if you have a task that needs to complete independently of whether or not the worker whether or not the consumer is running, you need to toss those to these things called workers. We do stuff like looking up things. We do notifications this way also, where we just sling events over to a worker to say, should a user be notified about this? Maybe they're not logged in, but they asked us to tell them if a particular workspace changed. This should happen whether or not the user is connected, but we don't want it to be taking up too much other stuff. So we toss them over to workers. Also, messages may be dropped for various reasons. Channels tells you this is going to be lossy. This communication may be lossy. Some messages may fail for whatever reason. Big messages, it turns out, can also be a problem. Sometimes either firewalls or browsers will say, this message from the consumer or from the worker to the client is just too big. Maybe firewalls drop it, maybe the browser doesn't like it, I don't know. We ended up having to auto-compress messages. So both the UI and the backend have a message type that is a compressed message. And if they get that, they decompress it and then re-queue it up for routing. Because we got to the point where, because I've been showing those graphs can get to 2,000, 3,000, 4,000 nodes. They get to a couple of megs. And you're sending a couple meg message down a WebSocket. Some of those firewalls look at that and go, what the hell are you doing? And those sometimes just close connections for that. So we ended up having to be pretty aggressive about compressing things also. Also, I mentioned all kinds of things can cause them to fail. The client connections can just go down for various reasons. Also, one of the things we ran into pretty regularly is security middleware products will try to inspect this, because when it's set up, the WebSocket, it looks like HTTP. And it has that special header I mentioned before that says, this is really not really HTTP, it's a WebSocket, you should upgrade this to a WebSocket. But some middleware boxes still think it's HTTP, and they're trying to inspect it over days and weeks. And one of the things that will happen will be they'll delay the responses. In HTTP, you don't really care if the response takes 5 more seconds than otherwise would have. In what you're trying to do as a real-time application, a 5-second delay through a middleware box is a killer. We actually had a problem with a customer who had one of those, and his requests would take 5 seconds to go through his middleware box and reach us, and another 5 seconds for the response to come from us back to him. And it got so bad that he was actually fighting with his own edits, because he would make an edit, he would add a node and have the default node value in it, and the add node message will be coming up to us, and in the process of coming back, he would have changed the name of the node, and then our confirm, yes, you added a node message would come back and overwrite that change that he had just made. He was getting furious. We had no idea what was happening, because as far as we could tell, we were replying to the message he sent and sending it back to him. The problem was that there was a message delay that was long enough that he could interfere with his own edits, basically, and interfere with the confirmation to his own edits. And we ended up having to get sort of fancy with locking the workspace. So when there's a message in flight, we had to say, hold on, we got to confirm this before you can make another edit.
So that still happens with TLS?
Oh yeah, because there's some of the sites especially will crack open TLS. They'll install a trusted root cert on the client machine and then forge the certificates to the client. So one of the things I mentioned earlier, the REST side and the WebSocket side don't talk unless you make them. So if you're doing that caching I was talking about earlier, they're not going to, it's not the stuff you have on the WebSocket side isn't going to know that something changed on the REST side. I mentioned the changing of metadata. The other thing that we ran into was a real problem was we have a way of we allow people to share workspaces between each other. And if two people are working in the same workspace and one of them loses permission to the workspace, a REST call says that share is no longer available to that person. The Django Channels side has no idea that happened. You have to instrument that communication yourself. So we actually had to create an event in Django Channels that is user lost permission. And then when the backend, when the consumer gets that, it closes itself. So we had to force that to happen because the Django channel side had no idea that anything on the REST side had changed. And because the channel side is asynchronous, it has no way to make periodic calls to say, do they still have permission, do they still have permission? And frankly, that's not the way you should be doing it anyway. So the channel side had no way of knowing. We had to instrument that communication ourselves. And channels, because there's so many different ways of doing that, the channels framework itself is not going to do that for you. If that's a thing that can happen to you, you need to instrument that yourself. Also, channels doesn't actually track the user connections because it's so asynchronous. That group thing I mentioned earlier, it will not tell you who's in a group because it assumes that this is something that's going to be so dynamic that there's no point in telling you because it's going to be wrong. So if you want to keep track of, here are the 5 people that are in a group, and here's their reply channels and here's their user IDs, you need to do that yourself. Channels will not do it. There is no way to list all the reply channels or all the user IDs in a channels group. For us, this actually mattered because we need to be able to do things like this user can see this workspace, but maybe not this particular node, or maybe they can see only part of this reply. And if you need to do that kind of filtering, you need to track that yourself, which is a little duplicative of what Channels is already doing, but they don't offer it. And it's come up a couple times in tickets, and they're really not going to offer it. In our case, because Channels on the back end heavily uses Redis, for those who didn't realize that, Channels is heavily reliant on Redis. Since Redis is already there, we're using that. We're just tracking membership of that into various Redis keys. But it is something you have to do. In general, though, I'm a huge fan. What we do in our application wouldn't be possible without it. I mean, again, I'll come back to this sort of real-time collaboration where multiple people can be on this at the same time. They can be adding stuff and seeing each other's edits happen in basically near real time is something that we just would not be capable of doing without something like that on the back end. So I'm a huge fan of it. And yeah, that's what I got. Questions? Yeah.
So I'm totally making this question up out of thin air because I've never had to do web dev.
Okay.
But I'm scared of it, and it's coming. So like, would this also be applicable to any use cases with Flask APIs, or is that a totally different scenario?
So I generally think of Flask, if you think of like REST APIs or Flask. So I generally think
let's
of.
Say you're trying to do machine learning, but all your crap is in JSON format because your client is cheap and that's
So for REST APIs, I generally think of Flask and the Django REST framework as being competitors.
Really?
If you're doing just pure REST, whether or not REST is the way you want to go is a whole other architectural question. One of the things, I was talking to the guy who built Channels, and one of the things he said was a common usage pattern for him. Actually, what he said he got the most support requests for were Bitcoin and various exchanges streaming price data to consumers.
But Bitcoin.
It's Bitcoin, that's why I didn't bring it in the main slides. But the use case is still there, that they have a consumer who's streaming data to them. They don't want to make a bunch of HTTP requests. They didn't feel like HTTP really worked for them, but they wanted to stream data to the client in the browser. And so that architecture may work better for you depending on how you're doing it. So yeah, you can try and pretend you didn't hear about it from Bitcoin. But it is still an interesting architecture.
It's legal.
Yes. Yeah.
So I'm working on an application now that is pure REST at the back end, which is currently split across a load balancer. So my front end talks to the load balancer. So potentially each session could be a different call.
Yeah.
We're talking about moving towards WebSockets for some communication. Would that be able to work in that kind of architecture, or would I have to kind of restructure?
You'll have to change. What you'll want to do is define the URLs ahead of time that are going to be sockets. And you can do that with Django URLs the same way. You can do it with the, with the same regexes to say this is the, whatever ID you want in the URLs and all that. And then take that URL pattern and give that to your load balancer to say, any URLs that follow this pattern, I want to go to these servers, which are my WebSocket servers.
Okay, so you would have dedicated WebSocket servers.
You probably will want to at that point. I mean, you could mash it all together, but like I was mentioning before, if you do, you run the risk of having the WebSocket consumers, even if they're just idle, sucking up all the RAM on the servers. So you probably will want to scale those separately.
Okay, thank you.
Yeah.
Yeah, I was curious. You said that you used Redis. You have, like we were just saying, multiple channel servers in the back end. Does it do routing between them automatically? Does it know one user is connected to one server and another to another and automatically route between?
Yeah, so what Channels is doing with Redis in particular is the groups I was mentioning before are under the hood are actually Redis pub sub queues. So when you join a group, every client, when you add a reply channel to a group, then that consumer joins a particular pub sub queue for that group. And when anyone writes to it, that consumer gets an event off that pub sub queue to say, I have an event for me now, and handles it. So they all need to be talking to the same Redis instance, and that's how they can talk to each other. Yeah?
Yeah, could you maybe say a few words about how Django Channels kind of compares, or maybe it's not related at all, but to the async IO module in the standard library in Python?
Channels is using the async IO library.
Okay, got it.
So it's a similar pattern of it's basically an event listener. Channels consumers are basically event listeners, and they just took away a lot of the framework of building up the event listener. They just said, you're going to get events. Define handlers for me for events of certain types, and it does the event loop and the routing and all that for you. But it's using the async IO library under the hood, which I was talking about. You can write async workers. That's what that's about. But like I say, the Django ORM is not async. And all of the hairiness that comes from trying to call synchronous code from asynchronous code still applies in Django Channels. They don't do that for you. Django Channels doesn't change Django really at all. And Django is not async. So if you're doing asynchronous code, you're going to have to put some wrappers in there to say, I'm async right now, but this bit of code is synchronous. You need to tell the async thing to stop, become synchronous for this block of code, and go back to being asynchronous again.
Thanks.
Yeah? Oh, sorry.
So I was just wondering about alternatives to WebSockets these days. I remember learning a long time ago about long polling. But now that WebSockets is well supported, I wasn't sure. Has everyone moved to WebSockets, or people still using long polling and stuff, or stuff I don't know about.
Everyone, I'm not sure I have a lot of visibility to be able to say. It's more a use case kind of thing. Like for an HTTP2, leaving a connection open for a long time, just having the server respond multiple times, it works. And the reason people don't do that and prefer WebSockets is you still have all the server headers and all the client headers in there. And that's more overhead than you probably want. For me, an event like set a node color, that's a really small hunk of JSON. And so I can handle a fuck ton of those coming in at once. The HTTP headers would get, if I had like an HTTP2 long-lived connection, that would get weird. I'd have a lot higher load to handle it.
And if you wanted to use that HTTP2 ability in Django, is it handled just like a regular request?
I don't know if Django handles HTTP2. I'm not confident it does. I'd have to check. I don't know. Cool. Yeah.
Do you know if Channels is still in development? I guess like how,
Oh, yeah.
how old is it? Like is there?
It's an official Django project now. It's under the Django.
Okay.
In GitHub, one of the sub repos of the Django repo overall is Channels. And the ASCII server and the ASCII communication standard are all part of Django now. So it is under active development, yeah.
Do you know if there's any new features that are coming down the pipeline for it?
Oof. Big features I'm not sure of. He's wrestling with a bunch of little things. There's problems people are having with like occasional communication errors where if, because it's so asynchronous, if someone doesn't kill like a sub-process, you get all kinds of crazy errors when the thing terminates. And he's working on things like that. He just did a big change about a little over a year ago, maybe a year and a half ago. Channels 1 to Channels 2 was a huge change. And I think he's sort of letting that one settle for a little bit. Because Channels 1 didn't really do class-based consumers at all. It was all methods. And so you had to manually map this event on this channel is this method. This event on this channel is this method. And Channels 2 is all classes. In fact, the rewrite for that was frankly awful. I actually talked to him about it and said, do you have any guidance for that? And his only answer was, I'm sorry. So I think he's letting things sort of settle from that rewrite for a little bit. Because I haven't seen any, I haven't looked carefully, but I haven't seen any big changes coming.
Is it tough to get people that are clients to trust you to use that kind of technology if there's those kind of big changes that come down the pipeline every once in a while?
I think people come to Channels because they want to use Django and do the real-time stuff. So, from that side, his main users are developers, and they'll roll with it because they want to use the Django side of it also.
What's the alternative?
In the Python side?
Yeah, I guess there's not much, right?
Twist, this is also using Twisted pretty heavily, and Twisted has pretty aggressive WebSocket support. And this is using that under the hood, but I'm not aware of a Flask plugin to handle WebSockets. There may be one, but I'm not aware of it if there is.
And in the JavaScript world, there's
a ton of libraries within JavaScript world to handle WebSockets, yeah. Yeah.
You mentioned several times he is working on it. Can you tell us who he is?
Andrew Godwin is the main author of Channels. I think he also did South, which turned into the migrations. So he's well known in the Django world anyway. Yeah.
Might be worth noting in terms of big changes, I think he's pretty heavily involved in Django core going asynchronous, so he may not be as focused on channels right now.
Mm-hmm.
So I just wanted to throw that out there.
Fair enough.
I doubt a 3.0 is coming anytime soon unless someone else kind of takes that up.
Mm-hmm. Okay. Yeah.
So you focus on WebSockets pretty heavily, and I was wondering if I haven't used Channels myself. Does it also handle other asynchronous protocols from the server, like server-side events?
I haven't checked, so I don't know. Most of its documentation and stuff is about WebSockets. So I'm not sure if you could sort of shoehorn this into that or not. I don't know. Yeah.
You're citing the 5-link WebSockets. consume server resources?
Sorry?
You were saying that idling WebSockets consume server resources. People have been connected for a week but aren't doing anything. Any thoughts on finding and killing those?
You don't want to. I mean, if your client is connected, they're still at that page. In fact, one of the bugs I ran into, which is a really interesting one, client is connected to, I have that application, people looking at a graph. People left that page open for like 2 weeks. It's a tab, they forgot it was open. They left it open for long enough that their Django session expired. But because they were making no requests, no HTTP requests, no WebSocket requests, the lifetime of their session never got refreshed. So their session really did just expire. And when they tried to then make another request, they came back to it 2 weeks later. But their session had expired, so all the authentication failed. We had to actually write some code on the UI side to say, yeah, if you get just an authentication rejected, make them reload. But the thing is, you don't know if someone's idle for 16 hours because they went home, but want to come back to it tomorrow morning, or if they just forgot about it. You don't know. So as long as that connection is open, you have to kind of leave it open because you don't know what your consumer's gonna do. Yeah.
How do you handle updates then? Like if we
So we have, so we're running this all in Kubernetes in a cloud, and we have a maintenance window that's fairly late in the evening. And what we end up doing is we kill all the pods. And that, we deploy a new version, kill all the pods, that kills all the connections. And we had to write code in the UI side to say, if your connection gets killed, try to reconnect. And if you get, if you get like connection refused or 500 or something, do an exponential back off. If you get authorization rejected, then redirect them back to the login page. Yeah.
Yeah, kind of building on the same things. Does Channels have any like ping pong built in so you can quickly detect if either side is gone?
There are keep alives you can turn on the WebSocket protocol itself. Just to kind of send a blank message that Channels doesn't even touch. It's just web server to web browser. Just to keep like firewalls from saying, here's a TCP connection that's been open for 6 hours and no data's gone down, I'm gonna cut this. You can have just blank traffic going back and forth across the socket. That's something you can turn on the socket itself. You don't have to do it in Channels. Yeah?
I've never used Redis, but I use Salary quite a bit. If Channels relies on Redis, does that mean you would if you had an existing app with Salary, would you look at transitioning away from Salary and just consolidating all your queues with Redis?
The workers that I mentioned earlier that do sort of the asynchronous tasks not connected to a client, people often look at that and say, fantastic, I don't need Celery anymore. And Andrew Godwin gets a little frustrated by that because it's not really designed to replace Celery. If you want, Celery does a lot of stuff about like scheduled execution of tasks, scheduled execution of events, and is a lot more aggressive about making sure things really got run than Channels is. So frankly, the workers in there are really all about tasks within the Channels framework itself that need to be run disconnected from a particular user. It's not really focused to be a replacement for Celery. And that's just, he didn't design it for that. Anything else? Yeah.
In your application that you're doing, the graph network, is that using a worker to go and send it to just everyone?
No.
It's like a group that
has all
users.
Right, so there's a group that both of these two are in.
Okay.
And so that's how the communication goes between the two of them. And so there are other workspaces. I've got 257 in my local thing. And each workspace is then a different group. So when there's multiple users in a particular workspace, they're added to that group. And then one change from this, what happens when I do say, where's my mouse? Here it is. This, the UI sends an event down the WebSocket saying update node, setting X and Y to a new location. And that update node message is then sent back up to the group saying update node ID whatever, X equals whatever, Y equals whatever. Cool. have I run out of questions? Cool. All right. Thanks, folks.